if I am looking to find the GCF, and I have numbers and variables, I just treat these as two completely separate processes. So I'm going to find the GCF of the numbers and the GCF of the variables. So let's say that my 3 terms are this. The first thing I'm going to do is look at the numbers, 5, 20, and 35. Now 5 is the smallest number, and I think to myself, this only has 2 factors, 1 and 5. So 1 is always a factor of everything. Is 5 a factor of 20? Yeah. 4 times 5 is 20. Is 5 a factor of 35? Yeah. 5 times 7 is 35. So my greatest common factor of the numbers is 5. Let's look at the variables. And what I'm going to do is I'm actually going to write out there's 2 n's and 4 p's. There's 3 n's and 1 p. And there's 5 n's and 2 p's. And as you get more comfortable with this, you may find that sometimes you don't need to write it out, but this is a great strategy to use if you feel like you're not quite sure. So what I'm going to do is I'm going to look for common factors. So I noticed that these all have an n in common. And in fact, they all have another n in common. But they don't have a third n in common, right? There is another n here and another n here, but not over here. So they don't all have it in common. But I do see a p in all of them. And just 1 p, because look, there's actually not another p here. So what they have in common is 2 n's and a p, right? 2 n's and a p, 2 n's and a p, 2 n's and a p. Those are common factors. Now there's other factors, right? Like, for example, 20 has other factors besides 1 and 5, but the 5 was the only one that was in common with all 3. So this would be my greatest common factor.